Hey y'all. Okay, so obviously you know I'm not at school. I am at home and I'm going to be recording some lessons for you guys. So I brought my Elmo home. So let me get this focused in and we will rock and roll. Okay, somebody emailed me. One of my students emailed and asked about last night's homework, so that's the first thing that I'm going to address and do this for you guys. Okay, remember that you are going to be going from one of the vertexes to the opposite side and you're using the perpendicular slope. So the worksheet that I gave you guys today had a table and I really liked that table, so I'm going to kind of go with that. This is going to be the segment that we're focused on. I'm going to start with AC. Okay, so the segment AC, I'm looking for a slope. I'm going to use rise over run. Rise 1, run 1, 2, 3, 4, 5, 6, 7. So the current slope is 1/7. The next column asks for perpendicular slope, so that's going to be -7 because it's the opposite reciprocal. And then we're talking about the vertex that you're going to be coming from. It's going to be opposite AC, the other letter that's not included, which is B. So what I'm going to do is I'm going to start at B and I'm going to go down 7. I don't want to go down 7. So instead of going down 7, I'm going to go up 7 and left 1. So up 7, left 1. That will still give me that -7. So up 7, 1, 2, 3, 4, 5, 6, 7, and then left 1. Okay? So yeah, it's off the graph, but that's no big deal. I need a straight edge. I'm going to use this pack of sticky notes. And voila. So that is my altitude. Okay, so that's the first of the altitudes using this handy dandy table. I like it. Okay, now I'm going to use AB. Okay, and I'm going to find the slope of AB. Okay, so AB, I'm going to use a different color pen, and I'm going to still find the slope. I'm going to use rise over run over here, just because I don't want to draw inside that triangle. So I'm going to go down 1, 2, 3, 4, 5, 6. So down 6, and then I'm going to go 1, 2, 3 to the right, which is a positive move. So down 6, right 3. If I simplify that, that's going to be -2. So I need the perpendicular slope, which is going to be +1/2. Okay, so +1/2. And what vertice am I going from? The one that's not included, which is C, because AB not included is C. So I come from C and I use a slope of 1/2. If I go up 1 over 2, that takes me away from the triangle, so I want to flip that and make 2 negative moves, because 2 negative moves is the same thing as a positive. Okay, so I go down 1, left 2, down 1, left 2, down 1, left 2. Again, I'm using my straight edge. I'm really sorry if y'all can hear cartoons in the background, but you know what? That's my life right now, at home with my babies. Okay, so that's the altitude for that one. We've got one more to draw. We're going to use the side that we haven't done yet. We've got AC, we've got AB, but we have not done BC. If you watch the video that I posted today by the other teacher, then you'll see that they used point slope form, which is y2 minus y1 all over x2 minus x1. That definitely works, and if you like that better, then you can use that. I'm sorry all my Facebook stuff keeps popping up. Okay, so BC over here, I'm looking for the slope of that. Again, I'm going to use the outside over here to count my rise and run. So I'm going to go down 1, 2, 3, 4, 5. So down 5, and then left 1, 2, 3, 4. Left 4 is also a negative move. So I've got two negatives. So that's actually positive 5/4. So the perpendicular slope is going to be negative 4/5. And I'm coming from vertex A because that's the one that's not included. So I go to vertex A and I need to go down 4, right 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, I'm using my straight edge. And ta-da. Alright, so we are looking for a single point of intersection, and I'm thinking my graph might be off because I don't see that. Let me count this slope and see if I did that one right. 1, 2, 3, 4, 5, 6. Hold on, y'all. 1, 2, 3, 4, 5, 6, 7, 1. No, that's correct. Okay, let me take a look at what the book has because these two clearly cross right here, but this pink one is off a little bit. So let me see what's going on. Maybe I made a mistake. Okay, I found my mistake. I did make a mistake, and it's with the pink one. You can see that I said the slope was 1/7 because I went up 1 and then I went left 7. So that should have been negative, which means the perpendicular slope is positive. So I do need to go up 7, but instead of going left 1, I need to go right 1. Okay, so this line is incorrect. So that's my bad. I could remake this video so that y'all don't know that I made that mistake, but you know what? Y'all know I make mistakes. So there's the correct line. Okay, so now you have a bullseye point where all three of them are intersecting in that exact same spot. So it is not in a pretty location, so I can't give it an ordered pair like we did in class and say 12, 12, but where all three of those lines intersect, that is going to be your orthocenter. Okay, let's try again and see if I can not mess this one up. Okay, so I love the table. I think the table is super helpful, so I'm going to use that again. So the segment that I'm going to start with is AB. I'm going to find the slope of AB. So I go down 1, 2, 3, 4. So down 4, 1, 2 to the right, which is positive. So that's negative 4 over 2. Negative 4 over 2 is going to be negative 2. The next thing that I need is the perpendicular slope, which will be positive 1/2. Then I need the vertex that I'm going to be leaving from. I have AB, so I'm missing C. So I'm going to go from C, and I'm going to use the slope of positive 1/2. Up 1 over 2. Up 1 over 2. So clearly looks like we're going away from the triangle, but that's okay. I'm going to flip it down 1, left 2, down 1, left 2, down 1, left 2, just to give myself plenty of points to figure out what is going on. So I don't know if you remember me telling you yesterday, but not all of these are going to intersect inside the triangle. Okay, and this one definitely looks like it's clearly not. Okay, the next segment that we're looking at, we'll just go BC. So BC down here, I'm going to go this way to stay outside of the triangle, is down 1, 2, 3. So down 3 and then right 1, 2, 3, 4, 5. Now, there's no way to simplify that, so that slope's going to be negative 3/5. So I'm going to do the opposite reciprocal, which is positive 5/3. And I'm going to be coming from A because I've got BC, so now I need A. So go up here to A, and I need positive 5/3. So I don't have enough space to go up 5, so I'm going to flip it and make both of them negative. Go down 5, 1, 2, 3, 4, 5, and then left 3. 1, 2, 3. Down 5, 1, 2, 3, 4, 5, left 3. 1, 2, 3. Okay, so I am sketching that out. Okay, it does look like these are going to intersect, but it may be off the graph. So I may have to extend it some here in a second, but I'm going to keep going. And the only segment left, I've got AB, BC, so now I need AC. That's the other segment. So this one, I'm going to go up 1, 2, 3, 4, 5, 6, 7. And then I'm going to go left 1, 2, 3, 4, 5, 6, 7. So left 7 is negative. So that has a slope of -1. So the opposite reciprocal is +1. And I'm coming from vertex B. Okay, so vertex B is here, and my slope is +1. So up 1, right 1, up 1, right 1, up 1, right 1. Or I could flip it and go down 1, left 1, down 1, left 1, down 1, left 1. Okay, so then I take my straight edge. It definitely looks, whoops, like these are going to intersect down in this direction. So I'm going to extend out these lines a little bit so that we can see that point of intersection. And I'll tell you just a quick little tip for those of you that have taken the time to watch this video. So it's going to intersect somewhere down here. If you've taken the time to watch this video, the reason why these are intersecting way out here is because this is an obtuse angle. Anytime you have an obtuse triangle, your point of intersection is going to be off your graph. Okay, it's going to be somewhere on the outside of your graph, versus these are all acute angles, and they're going to meet on the inside of the graph. So hopefully that helps while you're doing today's work as well. Know if they're obtuse, it's okay for it to be outside of the graph. If they are acute, then they are going to be somewhere inside. And let me just show you this. If you have a right triangle, like a 90-degree right triangle, you guys, are going to meet right here on the corner of that every single time. So these are your options for how they meet. Acute is within the triangle, obtuse is outside of the triangle, and right is right on the corner of the 90-degree angle. All right, I hope that helps. Thanks for watching this. I think you guys are awesome, and I will see you soon.